Hello everyone. Today, this nice little video for you on this asynchronous day is to help you review for the test that's coming in the next 2 class periods. So with this is a specific review found on Agile Minds over topic 3, our most recent topic. So again, this is the topic 3 review. Okay, so taking a look at question number 1 here. It says that each grocery cart at a store is 4 feet long. A line of grocery carts pushed inside each other is a length of one cart plus half a foot for each additional carts. Which statements are true about this situation? Select all that apply. So that means we're going to have to select multiple things. That's our first clue that there's more than one answer. With that said, let's talk about the information that they're giving us. So in question 1 here, they're giving us the length of one cart, which is 4 feet. Then for each additional cart added on, it's another half a foot. Okay. So with this, that gives us together our total length. Okay. So that means the overall thing that we're finding here is total length. Whenever we're looking for something overall, that is going to be our dependent variable. Okay. So with that said, if total length is dependent, that is dependent on what? Well, it depends on how many carts are in the line. So the number of carts is our independent. Nothing's going to affect that. Independent. Okay, nothing affects the number of carts, but the number of carts affects the total length. So with that said, if you remember correctly, we talked about when independent and dependent variables become functions, okay? And with that, we were saying that the dependent variable, so total length, is a function of the independent variable, so number of carts. Okay, so with this, let's go through these check boxes. It says the length of the line of carts is a function of the number of carts. Total length is a function of carts, so we'll go ahead and check that box. The length of the line of carts is dependent. Total length is dependent. The number of carts is independent. Well, we just said number of carts is independent. 0 carts would have a length of 3.5 feet. Just think about that for a second, guys. If there's 0 carts, is there any length at all? No. So we're not going to check this next box. And it says the number of carts depends on the length. Nope, that wouldn't be either, because we just said the total length is dependent. The total length depends on the number of carts. So that's going to be our first answer. Question 2. Question 2 is a graph. When it decides to load, there we go. Okay, so with this, it says each grocery cart at a store is 4 feet long. A line of grocery carts pushed inside each other is one cart plus a half a foot for each additional cart. So drag the points to create a graph starting with 1 to 10 carts. So we're not going to worry about the 0 mark. So I'm going to take this. One cart, we said, was 4 feet long. An additional cart is going to be those 4 feet plus half a foot, which means the third cart would be another half a foot to make our line a total of 3 long. 4 carts, we're going up a half a foot each time here. So 7 is at 6.5. 8 would be at 7 feet long. 9 would be at 7.5 feet long. Oh, I'm sorry, 8 would be at 7.5 feet long. 9 would be at 8 feet long, and the 10th cart would mean that our line is 8.5 feet long. Question 3. So on question here, it says, which function rule describes the data in the table? Okay, so the first thing we need to do, guys, I'm going to rewrite this table so it's up, down. I like my tables better this way. Okay, so it says -5 pairs with -11, -3 pairs with -7, 4 pairs with +7, and 9 pairs with +17. So the first thing I'm going to do here is I'm going to look for my change in variables. I'm going to look for my change. We did this before. If you guys remember, we did this in either one topic ago or 2 topics ago. I think it was the last topic. We looked to make up our symbolic relationship. So from -11 to -7, we're actually adding 4. We're getting closer to 0 there. From -7 to +7, we're going up by 14. And from 7 to 17, we're going up by 10. Now, this is not nice numbers like it gave us last time. So I'm going to go over here and see what this ratio is. And we'll learn more about this in the next unit too. So from -5 to -3, I'm looking at a change of +2. From -3 to +4, that's going to be a +7. And from 4 to 9, that's going to be a +5. Well, I can take any one of these guys. It doesn't matter. So I'm just going to stick with the first one. 4 over 2 means that I have a change of 2. So right away, I'm going to eliminate these first 2 things here. So I have to decide using my table if this is going to be 2x plus 1 or 2x minus 1. So what I'm going to do here is I'm going to take my points and I'm going to plug it into the equation. If I, using this 2 here, if I plug in, let's pick nice values. So I'm going to use 4 and 7. So I have the equation that y equals 2x plus 1. If I plug in 4 to the x, 2 times 4 plus 1, that's 8 plus 1, which equals 9. Well, is 9 my y value? No, I had a 7. So let's try the next one. Y equals 2x minus 1. So we're going to say y equals 2 times 4 minus 1. 8 minus 1 is 7. And that's what we had there, was a 7. So we're going to go with 2x minus 1. So question 4, the cost of shipping a package overnight from San Antonio to Dallas is $5.50 plus 85 cents per ounce. Which function rule could we use to find C, the cost to ship the package? So C stands for our total cost. Well, right here, guys, they tell us it's going to cost us $5.50. Oh, that was question 3. This is question 4. My total cost is going to be $5.50. And then they give us the word plus. Plus. So put a plus sign down. And then it says 85 cents per ounce. This word per, guys, that means multiplication. So I'm going to say 85 cents per ounce. Well, do we know how many ounces it is? No. So that's going to be my variable. So I need to find the equation that matches this, and that's going to be this one here. It doesn't matter that it's flip-flopped. The x is still paired with the 85 cents. Question 5. Okay, so question 5 says that an amusement park charges $25 to enter plus $2 per ride ticket. Well, in order to understand this, okay, I'm going to write something out here. Our total cost, they said it's $25 to get in plus $2 per ride. So $2 for each ride we take plus the 25 to get in. What this means, guys, is that just to get into the park, it's going to cost us. So for 0 rides and just to get in, it's going to cost us $25. So I need to go to the graph that shows me that my starting cost is going to be $25. So we're looking at graph A and graph C. Okay. So now we need to determine $2 per ride. So here, because we have a 10 in both of these, let's go ahead and see what this $10 gets us. So I know that if it's 25 to get in, and I go on one ride, 25 to get in plus one ride, so 2 times 1. So it's going to cost me $27. So I look at my graph and I see about one ride, 27. That looks like it's about at 27. Let's go over here. Now again, it's starting at 25. Okay, that's kind of hard to see. So let's go to this next step. Let's go up. The big thing here is let's notice how much it's increasing by. Here, if it starts at $25, I see to get to $30, they're saying we got to ride 1, 2, 3, 4, 5 rides. Well, wouldn't 5 rides at $2 a piece? 25 plus 2 times 5 rides. That would be a total of $35. $35, and they're saying it's only 30. So let's check this over here. If we're at 5 rides, so that's about our halfway point here. There we go. That's about our 35. So we're going to go with graph A on this one. Question 6. So they want us to calculate C of H, the cost of a repair, and a mechanic uses the function rule C of H equals 35 times H plus 35. H is the number of hours it takes to complete the repair. So we have this function rule of C of H equals 35 times H plus 35. Okay, remember guys, we talked about that this C of H is just a fancy way of saying Y. Okay, that's the same exact thing, or we could say C, the total cost. Okay, what they want us to see is that 2 hours. So I'm going to go back to my regular function notation. The cost of 2 hours is 35 times the 2 hours plus 35. This gives me 70 plus 35. So the cost of 2 hours equals $105. That sounds about right. Okay, looking at number 7. Number 7, they want us to write a rule on number 7 here. Okay, so it says Tim wants to buy a new computer system. He saved $35 last month and plans to save $20 a month until he saves at least $300. Which function rule, so which equation, models the relationship between M, the number of months he'll need to save for his game, and T, his total savings? Well, let's talk about his total savings. How much does he have? Well, right off the bat, it tells us he saved $35 last month. So he has $35. And anytime you see the word and, that's a plus sign, $20 a month. So $20 for each month he's going to save. So finding the equation that looks like this. So 35 plus 20M equals our total. Question 8. Okay, question 8 here. Anna has saved $525 for a new flat screen television. She plans to save an additional $50 per month. A function rule to model the relationship between the number of months she will save M and her total savings S is S equals 525 plus 50M. So right away, guys, write that down. S equals 525 plus 50M. What is the shortest length of time she will need to save money in order to have enough to buy a flat screen television that costs $1,225. Well, if she needs to save up $1,225, we're going to put that in the S spot. We want to know how many months. Okay. So we're going to say 1,225 equals 525 plus 50M. Now, if you remember, I know in a couple of your classes, we talk about solving two-step equations. Okay. We need to get Stinky by himself. So with that, I'm going to draw this wall. This 525 and this 50 want away from Stinky. They want outside where the air is clean. So step one is to move what's furthest but on the same side as Stinky, and that's going to be our 525. It's addition, so I'm going to subtract 525 from both sides. That leaves me with just the 50 times Stinky over here. And on the left-hand side, if I subtract that, that leaves me with $600. Now, again, 50 wants away from Stinky. That's multiplication, so that means we need to divide both sides by 50. And then Stinky's by himself, and all those numbers put together equal a total of 12. It will take her 12 months to save up the money she needs for the TV. Question 9. Miss Kai is going to rent a moving truck for 3 days. The rental charge is $85 per day plus 25 cents per mile. She wants to spend no more than $300. Which rule models the rental cost of the truck? Rental cost of the truck, so the total cost of the truck, C, equals, and then as a function of the number of miles driven, M. So what does it cost for a rental truck? It costs $85 per day. We'll call this D. Plus, it tells us plus 25 cents per mile. Okay. So again, guys, we have D, which stands for day, and M that stands for miles, and C is our total cost. Okay. The problem is we don't do 3 variables. So is there a piece of information we do know that we can fill in? Let's go back. Miss Kai is renting a movie truck for 3 days. So right there, we know that she wants this for 3 days. So we're going to say that cost equals 85 times 3 plus 0.25 M. So let's go ahead and simplify that out. And that gives us that her cost is $255 plus 25 cents per mile. And we have that option here. And then lastly, question number 10. This one's hard, guys. This one is a hard one, not gonna lie. So we have an athletic team uses a round design as its logo. It appears in many sizes on clothing. So the table of values describes the circumference of the circle, Y, as a function of the length and diameter. Which of the following function rules can describe this relationship? And they go ahead and tell us that the formula for circumference of a circle is C equals 2 pi r. So circumference equals 2 pi r, and r stands for radius. Okay, so a couple things to note here, guys. We have Y stands for circumference. Sorry, can't spell today. My X stands for the radius. Now, there's something maybe you guys remember about the radius. See, now I messed things up. The X stands for the diameter. But the problem is that in my formula, they're giving me R for radius. Is there anything that we can think of with diameter compared to radius of a circle? Okay, maybe you remember this, maybe you don't. So I'm going to go ahead and give you this information. The diameter is the length all the way across the circle, where a radius is just halfway. So it takes 2 radius to equal the diameter. Okay, so if I look at my formula, my circumference equals 2 pi times radius. And if r equals 2d, that should be a d, not a 6. 2d, okay? They want to know which of these equations will work, okay? So the first thing I need to do, I need to exchange my c for a y. We know my pi is in the problem, okay? But now we need to talk about this r, okay? If 2 r's stand for a d, then we can call this pi d, okay? And in this problem, remember, diameter is x. So this is really going to be an x. So we're going to have y equals pi x. So right away, I can check off this box, okay? If you guys remember the commutative property, maybe you guys have seen the TikToks, we're twins, we're twins. I am me, she is she, except when we switch or something like that, okay? That means the same thing as y equals x times pi. 2 times 3 is 6, and 3 times 2 is 6. So I'm going to go ahead and check this box here, okay? Now let's look at this line. This one gets a little bit tricky. And I'm going to go ahead and write this option out for you guys to see. Y equals 2 pi, and then they've got x over 2. Well, all that happens here, guys, is my 2's cancel, and it leaves me with y equals pi x, which is the same thing we have here. Okay? We don't want 2 pi x because we just said pi x is an answer. Then we come over here and we say x over 2 times pi. Well, again, that doesn't match these up here. So these are our 3 answers. That one's a hard one, guys. I don't expect there to be something that difficult on the quiz test. Okay? And with that, guys, that is the end of the review. Please let any of us teachers know if you have questions. Have a great day.